Okay, this is part 2 of our lesson on transformations. And so we're going to look at reflections right now. We're going to look at some examples. Suppose we have the function f of x equals square root x. That's one of our basic functions. We know the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2. Let's go ahead and plot those points to remember what that graph looks like. Okay, so next what we want to do is multiply the function by -1. So you can see that I have the negative outside of the square root. So take the square root of 0 and then multiply it by -1. You still get 0. Take the square root of 1, then multiply it by -1. You get -1. Take the square root of 4, then multiply it by -1. You get -2. So when we plot those points, we see that our graph has been reflected across the x-axis. So this is what happens when you multiply a function by a negative. Notice that negative is outside the square root sign. So I like to say it's outside the function. Okay, now let's take a look at another way to reflect a function. This time I put a negative inside the square root sign. So let's find some points. If x is 0, the opposite of 0 is 0, square root is still 0. If x is 1, the opposite of 1 is -1, and the square root of -1 is not real. And when we're graphing, we're talking about real numbers only. So 1 is not in the domain. So how about if I switch gears and I try -1 instead? So the opposite of -1 is 1, and the square root is 1. -4. The opposite of -4 is 4, and the square root is 2. So if we plot these points, 0, 0, -1, 1, -4, 2, what we see is compared to our original graph, which was up there, this one is a reflection across the y-axis. So if you multiply your x by a negative inside the function, you will reflect across the y-axis. Now what happens if we do both? So you can see here in my equation I have a negative on the outside and a negative on the inside. So we could expect to see a y-axis reflection and an x-axis reflection. We can get a few points in there. If x is -1, the square root of the opposite of -1 is 1, and the opposite of that. If x is -4, the square root of the opposite of -4 is 2, and the opposite of that. So we have 0, 0, -1, -1, -4, -2. We have a graph that has been reflected both across the x-axis and the y-axis, and we actually call that an origin reflection. It kind of looks like you took the graph and you spun it about the origin 180 degrees. Okay, so let's generalize these. These work for any kind of function, not just a square root function. So if you change your function from y equals f of x to y equals the opposite of f of x, that causes the graph to reflect across the x-axis. If you change your function from y equals f of x to y equals f of the opposite of x, so the negative is inside the function, not outside, that causes the graph to reflect across the y-axis. And if you multiply your function by a negative on the outside and a negative on the inside, that causes the graph to reflect about the origin. X-axis reflection and y-axis reflection. Okay. What we're going to do next is just a few example problems. So example number 1, we have f of x equals the opposite of x minus 1 quantity squared plus 4. So notice I have 4 graphs here, and that's because I'm going to break this down step by step and show each transformation separately, starting with the parent function. So we know our basic function y equals x squared. Our basic squaring function, I'm going to plot a few of its points here, like 0, 0, 1, 1, 2, 4, and then on the other side, -2, 4, and -1, 1. And then the next thing I'm going to do is subtract 1 from x. I'm kind of building up to that final graph. So remember we saw that if you subtract a positive inside the function, you actually move the graph to the right. So let's move the point that was at 0, 0 to the right one, and then move all the other subsequent points to the right one as well. Okay, now I'm going to multiply by a negative. That's the next step I see happening to this function. And that negative on the outside of the squaring is going to reflect it across the x-axis. So any point that's already on the x-axis is going to stay there. And then let's just reflect those other points. And we get this. And then finally, let's add the 4 to get our final graph. So we're going to shift our entire graph up 4 when we add 4 on the outside. And what you could do is use your graphing calculator to double check this. And you could also plug in a number to double check that that point is actually on your graph. Okay, something similar, but this time it's a different parent function or a different basic function. We're going to use y equals the absolute value of x, and eventually we want to get to f of x equals the negative 2 times the absolute value of x plus 3. So remember your absolute value graph. It has a vertex at 0, 0 as well, and it's a V shape. Let's see if I can make that straight. More or less something like that. Okay, so then what's going to happen if I add 3 inside, add 3 to x inside the absolute values? That's going to shift it left 3. And then what's going to happen if I multiply it by 2? That's a vertical stretch 2 times as tall. So you can take a point like negative 3, 0, and it's still going to be at negative 3, 0. You have to double the y-coordinates of the points. If you take the point here at negative 2, 1, you have to double its y-coordinate, and you're going to have negative 2, 2. And so on, double all the y-coordinates. And then finally, we're going to multiply by a negative, which is going to reflect it across the x-axis. And there we have our final graph. Sorry, mine's a little sloppy. Okay. Now what we have is a graph that's actually not a particular function we have the equation for. We're just going to call it f of x. So this graph here, doesn't matter what its equation is, we're just naming it f of x, and what we're going to do is sketch g of x equals f of x minus 2. Okay, so if g of x is f of x minus 2, what we've done to f of x is subtract 2 on the outside of the function. That's going to shift it down 2 units. So just look at the points on the graph of f of x, find the points that are convenient to shift, and shift them down 2. And then go ahead and connect them, making the same shape as the original. Number 4, we're starting with the same original function f of x, and we're going to sketch the graph of h of x equals f of x minus 2. Look how the minus 2 is inside the f, so it's just x minus 2 inside the function. That would be, for example, like if you had squaring, x minus 2 inside the squaring, or if you had absolute value inside of it. So that is a shift to the right 2. So let's take this graph and let's shift the points that are convenient to work with over to the right 2, and then we'll go ahead and connect and get the same shape. And then one more. So this time we have the x plus 1, so that means we're going to go left 1, and on the outside the plus 2, that means we're going to go up 2. So take the points, and then I'm starting here at this point, negative 4, 0, and I'm going to shift it left 1, up 2, and then the point negative 2, 2, left 1, up 2, the point 0, 0, left 1, up 2, the point 1, negative 4, left 1, up 2, and the point 3, 0, left 1, up 2, and then connect those and get that same shape, and there we have it. Okay, so your homework assignment is here. Thanks, everybody. Appreciate it.